Welcome to a new test and teardown video. This time it's an analog multimeter. Goerz Electro, they're also called ABB, Metrawatt, and this one is a Unigor 1P. There are many different versions of this meter, and I think I got more or less all of them. So hopefully I will do a long series about all of them. But I guess this will be the first one. We see here on the top some extra banana connectors. So they're hidden here to make room for them. It's probably because this 12 millivolt input is something you don't use so much. But of course you're going to use this a lot, right? So this will be the ground, and this is the voltage AC or DC input, and that will be the current input. They block the hole so you don't put in a banana, because this is the high current input. So you need to screw in your wires here for high power, high currents, right? I think this is the resistance test, so you'll save the battery. Well, this will be the resistance 0. There's a convenient button for reverse. I think the old early multimeters or analog multimeters, they really had this reverse button quite a lot. I've seen this many times on multimeters. And voltage is full range is all the way from 60 millivolts to 1200. Not a lot of, 4 ranges of ohm. And a lot of ranges for current. I guess this is the offsetting. There's no indication on that. And then we got some extra settings down here. So that will be DC, resistance. So you need to, I don't know, do you need to put this in resistance when you do this at the same time? That's a little bit confusing. It's a really big instrument, and I really like the rear plate is a complete. This is like the one sheet manual thing where everything you need to know is written, technical data, so that will be all the specifications. And here you can see the internal resistance in the different voltage ranges. You can see the voltage drop in the different amp ranges. So very useful information. It also says something about frequency ranges. Man, it's really well done in a one sheet. How to connect, and how do you do this and how do you do that. And I've been looking in my collection and found the most beautiful back plate here without any scratches and stuff, so we can read everything and see this little thing. So this back plate comes in all the different languages. So if you search on the internet, you'll probably find them in English and German, but this is the Danish version. Temperature sensor and the 12 millivolt range. Isn't that something? Of course it says here how to do all the other amps, and this is the 30 amp range. Wow, 30 amp, that is something. And there's a battery in it. It says do not forget to check the battery. I think maybe we should just check the battery first. That was easy. Spare fuses and a little piece of tape so they're not gonna fall out. No battery was in here. Thank you so much for removing the battery when you store stuff for a long time. Wow, that was intelligent. So there's a adjustment screw. Oh, this is a seal. Look at that. This is an easy to break seal. This reveals nobody was in here before me. I kind of like that most, because that means I get stuff that is in really good quality. So there's a trimmer. Is this some sort of adjustment? I don't see anything explained about that. Maybe I can find a better manual online, but okay, so without the battery we can't do any ohms, at least. This is a little bit of a funny size. It says a half size. Damn it, I don't have those batteries. I don't even know where to get them. So without the battery, I guess all we can do is give it a little bit of DC voltage. See what happens. So this is 60 millivolts. So that will be this one and that one. And then 60 millivolts is full range. And look at that. So if I go really close, I mean, I am not able to see any error here at all. So this meter is super accurate. Let me try and turn off the voltage. So that was plus 50 millivolt, and now I know that my DC supply actually gives negative 10 millivolts when it is off. So when I hold this, it depends on the load resistance. So this one is probably loading a little bit more. So this is why my negative is only a few millivolts. That is funny. So when we turn on the voltage again, 50 millivolts. So let's go to the next range. That will be 600. And I think we're gonna use 100 as a starter. Whoa, that was 100 millivolt. And that is super accurate as well. And then we just crank it up 200. I mean, have you ever seen an analog meter 300, 400? I mean, that accurate. That is amazing. How is that possible? Let's try the next range. 3 volts. Okay, so that was 0.5. And that is 1. And then we go to 1 step. So that will be 2. And that will be 3. So this lamp is just annoying. So that is 3. Okay, let's go back again to 2. See if that is... Yep. I mean, we got a new world record winner here. 12 volt. I can continue with this all day long, but I think I will not bore you with any more of this. What is that? Is 10. Okay, this thing just is amazing. How about we try the high voltage ranges? Let's just skip all the small talk. Should we just try this? And this is 1000 volts, and it is only a tiny little. It is. I think it is visible to see that it actually reads a little bit under 1000. But yeah, it truly works. Let's try and dial it down to, what is that? That is 600. Yes, 600 is quite right. So the lamp just continues to bother me. So let's see if we can do this at the same time. And that is 600 to the last quarter of a millimeter. Fantastic. Let's try. Oh, we can't try AC. No, because we need the battery for that. I need to go and find one. Now I'm in AC, 600 millivolts. And yeah, almost 600 millivolts in AC. And obviously this is the lowest AC range, because this is a DC range only. They showed this with this little marking. And see, I tried to crank it down there, nothing happens. It's only DC. So there's of course a diode in here, and the higher you go, the less error there will be. So this is the worst possible range to test AC. So this is 50 Hertz and 600 millivolt RMS. So let's try something funny. So this is 50 Hertz. How about 60, 70, 80, 90, 100? Still it is the same. Okay, 100. Let's crank it up. Okay, that was 2 kilohertz. Still quite alright. 2 kilohertz. Alright, let's see. Is this 10 kilohertz? Really? 20. Okay. And then, okay, and it's off. So all the way to 20 kilohertz. Is this good and accurate? Wow, that's a little bit impressive. Okay, I found a problem. So this is ohm. And this one also needs to be in ohm. Yeah. No. What is this R thing? I don't get it. So, because now I shorted the two inputs. So I thought this was supposed to be an R. But that is not the case. Now, because I couldn't get it to read. Maybe this is all wrong. Maybe I'm an idiot. No. I don't get it. And then it's just cranking all the way out of the scale. See, there's no way I can change this. It's just hammering up. And if I put it in R, I really thought that was the resistance, and then I get a reaction on this knob, but I can't dial it all the way up to 0 in the 1 ohm range. But if I go times 10, then it works. But again, it's a little bit confusing. I need to use this. What if I do, see, nothing, and then how about I try and do this again? See, nothing, and then it just hammers out. So I don't know, and I don't think this is really well explained here. See, I am supposed to connect. I am supposed to connect the resistor, right? In this one. And but it does not work. This is so, but it doesn't say nothing about that, right? So I bet there is maybe the fuse is broken, but we'll have to open and see. So this one I thought was an adjustment. That is the fuse. So it was not the fuse, and that is okay. So now we need to open. It's always easier if you use the right tools. I really like this tool. It works all the time for these really annoying nuts. Easy, easy. Now we're inside. And with 3 PCBs on top of each other, stacked like that, with wires and stuff in between them. And of course it's full of resistors and stuff like that. And of course this is a 30 amp meter, so in here, let me see if I can get some more light. That one is not the 30 amp, but down here is the heavy duty. That is the width of the sense resistor. Come on, baby. It is that massive. The one to the right will be the 30 amps, as far as I can guess. We got some other sense resistors up here. So this is really tough. This is made to handle big currents. Look at the thickness of the material. Fantastic to see that. There will be, of course, some AC. They call this a Wendler. All sorts of different windings connected. All sorts of weirdo. What the heck? And this is a gas discharge tube. So that is a little bit funny. A PCB resistor. You can calibrate by soldering. PCB resistors are really not accurate. And over here. So this button is indeed the current overload button, where you can reset. So that is a relay. So now it is engaged, or its current is of course going through this. So this will be, yes, exactly. And then I push the button. Oh, real hard to charge this spring. So what moves this? Yes, that is the what. Ooh, we got some super sensitive. So here is also a mechanical, or like a gearing. So a very little current here will move this a little bit and then release this. That is really a funny design. Okay, so far so good. We got a diode here, and it's going into some of this current stuff. This component, I don't know what that is. There's a tiny little wire and a hole in here, and there's a plastic tube all over this. So let's try and, can we maybe? No, we cannot. So what is this idea? Ooh, this is probably a no-touch component, but I was looking in here and I saw some funny stuff, and now I really want to know what that is. So I was able to put the little yellow thing off. I guess this is a power resistor where you can super fine tune the value, and then you solder the tip of the resistor wire to the exact point. Also, I found why this instrument is so amazingly accurate. Look at the resistors, 270.4, and some are 1%, some are 0.5%, and so on. So they picked exactly the values they needed. There's no funny stuff done here. No expense saved. This is a little bit of a funny resistor that is there. And the color or the glue added to this, I am a little bit worried. What is that? I finally figured this out. It was me who didn't read the manual as accurate as it was supposed to be written. Look at this. We got 3 different kind of modes or features for ohm. However, I don't think the manual says something about where this should be, but I try the R position for that. Okay, ohm. Let's look a little bit here. So I need to plug in something and then adjust for full. Look at that, now it's open. I can remove this one. Okay. The fun thing is, if this one is taken out, it is kind of disconnected. And as soon as I just touch, see, As soon as I touch, I don't even need to put it in. Only touch. Boing, full range. And yes, it does respond now to the knob. Full range adjustment. Da, 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 da. So I can crank it to 0. So there's a little bit the other way around here, and this is exactly what confused me. And now I am in ohm, and none of that. So it must be this one. See this little symbol here? So this is where we are. And it is open. Let's try and connect. Nothing. Okay, what have we got here? A resistor. Let's try and measure that one. And this resistor is 10 ohm, wouldn't you say? And let's have a look. And if we are in this range here, look at that, 10. So that is accurate. So this mode goes all the way from 0 to 100, I guess. So let's try the next one. And this one is a lot different. See, the next mode, ohms times 1. Then you need to connect differently. So first, I guess, you connect those two, and then you do the calibration for 0, right? This is what I'm going to try. So let's do that. Pull all this. Okay. Let's go to times 1. Ooh, nothing. Okay, great. Let's connect between those two. And, oh, I need another hand. Circuit the bananas. And of course, it's connected like they say here. We are in ohms, fantastic. And it does indeed respond to the 0. And we are 0. And just a thing to see, in this mode, now the scale goes the other way. And this is of course what confused me. So that was the first mode, and now we're here. So that is 200. And wouldn't you say this is a 200 ohm resistor? Yep, I would say that. You move bananas, ranges go the other way. Oh man. Where is this meter most accurate? Up in this area or down in this area? Obviously, the different resistor values, they go like closer and closer here. So it's more and more difficult to say exactly where you are, right? So I would say this is 2000. And yep, 2K. Oh, I just found out something more. This is really, really interesting to study. This is the last range, so if you want to go in the kilo ohm ranges, look at the details they say here in the manual or the manual sheet. So if you are in the first 3 ranges I've just been playing around with, this will be the ranges you can measure, and then the voltage source is your 1.5 volt battery. Fantastic. But if you go in the kilo ohm range, that one, you can be in either a DC or in AC modes. Now, the voltage source is an external voltage of 100 to 130 volt DC or 100 to 240 AC. And this will give you the ranges. So here's how you do that. You take your voltage source directly into the meter, and then you adjust for full range. This is what they say you do. Then you put in the resistor you want to measure, and then you can measure the value directly. Whew. That is a little bit complicated, but this is of course because the meter itself don't have this kind of sensitivity, and there isn't any amplifying transistor tubes or funny things. So of course you need a very high voltage to measure very high resistor values. Phew, that was something. Of course, when you go and test currents, you need again to remember to switch this one. Otherwise, there isn't any other indication other than that it's just going to be very inaccurate. See? Ugh. Of course, in AC you don't get anything. But I think this is a reason for errors. You're gonna forget this. So it's better it's not reading anything, right? So this is 0.3 and we'll be in that range, and I am at the moment giving it exactly 300 milliamps. Let's give it 200 and see what happens. I mean, this meter is just amazing. Once you learn how to use this, it's just so accurate. It is really as accurate as you can imagine is possible. See if okay, it's just, oh man, this is crazy. Let's go 1.2 full range, and this is again my, so that means this is again my 0.2 amp that I'm putting through, so this will be the top scale, right? Yes, that is how it is, 1.2. Okay, so we can just dial up the current, 0.5, and that will be 0.6. Yeah, I think if I give it, ooh, complaints and stuff. What can I do in the 6 amp range? Do I need to move anything? And this is just 1 amp, and that is accurate. I'm getting absolutely frustrated about this beeper. It's stressful. How about we give it 3.0 and just bear over with me the noise. What happens if I go to the 30 amp? So how is that working? Okay, so it's those two. All I have to do is just move this. Ugh, no. So we are in the, well, 6 of course, but I moved this to here, so we are in the 30 amp range. So this is where we are, and I'm only going to give it 6 amps. So I expect to be right here if this is working. And the power supply goes absolutely nutcase. All right. So I really approve this instrument. It is totally working and insanely accurate. You should definitely get yourselves one of these if you are into analog meters and you really want to read accurate. Thank you.